गो।
हुआ?
यस,
अभी नहीं हुआ।
स्टार्ट नाउ।
नहीं, अभी नहीं हुआ ना, मोबाइल पे नहीं आ रहा। Hello, my dear students. Sorry for the late, as there is a small technical issue. Welcome to the session. How many are there? Please share and subscribe. Please share and subscribe. Those who are coming new, share the channel, subscribe the channel. We are going to have a lot of initiatives in this channel. Unacademy GATE. Please, all of you, share the channel, subscribe the channel. Unacademy GATE English. Okay. Welcome students. Today we are going to have a session on preparation strategy for signals and systems for GATE 2022. Already GATE 2021 was completed last week only, and I think most of you have seen the paper and the memory based questions, and we also provided most of the questions. Now those who are in second year or third year, if they are going to prepare for GATE, what is the strategy they have to follow? And this session is for exclusively for three branches, namely ECE, electrical and instrumentation people. ECE, electrical and instrumentation people. But before starting the session, I want you to share the channel, subscribe the channel. Those who are coming new, please subscribe the channel and share in many ways. Please. Okay. Now, let me introduce myself. Myself, KV Swamy. I did my MTech in Systems and Signal Processing from JNTU College of Engineering, Hyderabad, and I passed out in the year 2007. And since 2009, I was into this GATE coaching field, teaching my favorite subjects, signals and systems, and communication throughout the country. Total, I have 12 plus years of teaching experience, and in this teaching experience, I am responsible for many students in obtaining single and double digit ranks throughout the country. I have experience throughout the country, students. Okay, this is about myself, and now I am associated with Unacademy, and if you want to take a subscription in Unacademy, you can use my code KVS Live, with which you will be getting 10% discount on any course in Unacademy. You can use the code, you can save this code KVS Live. You should not forget this code KVS Live. You should save this code. If you want to take any course in Unacademy, whatever the course it may be, you'll get flat 10% discount on the course. And now I'm into this GATE stream. Now, what are the subscriptions basically we are having in Unacademy? Unacademy provides two types of subscriptions for GATE, namely the plus subscription, and the second one is iconic subscription. The plus subscription is a subset of iconic subscription only, in the sense that all the facilities what are available for plus subscription, they are available for iconic subscription, but there is an advantage with the iconic subscription. But what is that advantage? We'll see. Before that, let me tell you about the plus subscription. Here, the student is exposed to live classes in plus subscription, and structured schedule is given, and number of test series are also conducted, and you have unlimited practice questions. And apart from this, we have one more kind of subscription in Unacademy, which is nothing but iconic. How this iconic subscription differs from plus subscription? Here in iconic subscription, you will be under the supervision of a experienced educator. We'll call him by the name mentor. You will be under the supervision of a experienced educator called mentor, or here it is given that personal coach. You'll be having a personal coach who will be monitoring your progress periodically. And here also we are having study planners, experts guidelines will be having, and ESE mains question and answers also will be provided. And we have more like rank improvement batches, crash batches, and many initiatives are there in Unacademy. Now going to the next slide, suppose if you want to take a subscription in Unacademy, coming to plus subscription, if you want to take a 12-month subscription, it costs around 27,225 rupees for 1 year, which is ideal for final year students. And if you are going to use my code KVS Live, you will be getting flat 10% discount. Flat 10% discount means around 25,000. You see how much beneficial it is. Suppose if you are aiming for 1.5 year subscription, that is 18-month subscription, it costs around 34,650 rupees. And if you are going to use my code KVS Live, again you will be getting flat 10% discount on the course. Again, if we are having one more kind of subscription, my dear students, which is nothing but 24 months, means 2 years subscription, which is ideal for second year students. Second year students, if you are planning to take this one, it costs around 39,600 rupees. And if you are going to use my code KVS Live, you'll be getting flat 10% discount on the course. Apart from this, as I explained earlier, that we are having iconic subscription also, where the student will be under the supervision of an experienced educator known as mentor. Now, what is the fee structure in iconic subscription? For 12 months, that is 1 year subscription, iconic here costs around 45,225 rupees. And if you are going to use my code KVS Live, you will be getting 10% flat discount on the course. Again, if you are going for 24 months, that is 2-year course, again here the cost is 66,600. Again, if you are going to use my code KVS Live, you will be getting flat 10% discount on the course. Right? This is about the fee structure in Unacademy. I can say that if you are going to take a subscription in Unacademy, you will be having many benefits, multiple benefits. Or simply you can say that Unacademy subscription, one subscription, multiple benefits are there. Multiple benefits, many initiatives. Daily one initiative is going to come which will be benefited to the students. Okay. Now let me get back to our course. See, today I'm going to have a basic plan. From tomorrow onwards, we are going to start the subject signals and systems on Unacademy GATE English channel. And believe me, students, this is going to be the best course on YouTube, where the students is exposed to different problems. If the students is having minimal knowledge, if he knows how to do addition, subtraction, multiplication, division, small trigonometric identities, and small integrations, differentiations, and if he is from ECE, electrical or iron branches, instrumentation branches, he can happily attend the class and he can get the entire knowledge of signals and systems. Here the course, I mean, if we are going to start the course tomorrow, I mean, you can ask, definitely you will be having a lot of expectations from the educator who is teaching, and even I am having a lot of expectations from the students who are coming. So forget about my expectations, that we'll see at the end. First of all, let me talk about your expectations. And as the course, I mean, the name of the course is Signals and Systems, and today I'm going to give you a blueprint or a plan of this and or the structure of the course, how I'm going to deal. See, again, before going to start, let me tell you that this is the course which is ideal for second year students, third year students, final year students, and those who are given GATE 2021, and those who are not happy with the result, and those who want to repeat, or those who are going for ESE prelims, prelims or mains. This course is ideal one. That's why in the beginning only I said, most of you, I told you to share and subscribe. Share and subscribe the channel. You are going to get a lot of benefit from this channel. Okay, going back to the course. See, I divided the entire subject of signals and systems into different units. So a student from second year or third year may be getting some doubts, or I mean, I'm not able to understand the subject in my college, or I'm unable to understand if I go through the textbook, lot of doubts are coming and I'm unable to attempt the problems. Even in my university exam also I'm unable to solve, and I have having less marks in this signals and system. Means don't worry, this is the best destination. Unacademy GATE English is the best destination, and your problems are going to be solved from tomorrow. But I have some expectations from you people also, but that I'll reveal later. But let me tell you in what way I'm going to start the subject. Here, the first unit, I classify the subject into different units, students. The first unit is basics of signals and systems. Any subject, the first unit is basics only. And here, how many points I gave you? 6 points I gave you. Before going to discuss those 6 points, let me tell you one important information, that if you want to understand the rest of the units, that is the first unit is basics of signals and systems. The rest of the units, if you want to understand, you must thorough with the basics. You must thorough with the basics. If you are thorough with the first unit, everything will be done, because signals and systems is a kind of subject, which is interrelated. Every concept, suppose if you are in the second unit, it is interrelated to the first unit. Suppose if you are in the third unit, so you must have the strong foundation on first and second units. Otherwise, you cannot understand the third unit. Suppose if you want to understand fourth unit, you must have a strong base of the first, second, and third units. And this is like a chain. What I'll always say is, this is like a chain where we have a connection. So what I say always is that don't break the chain. If you are breaking the chain, means, let me tell you student, very difficult to attach. So if you are following my guidance in a correct way, definitely you will excel the subject. Okay. First of all, I'll be starting with the definition of a signal. What is the definition of a signal? Day-to-day examples, what you can give as a definition of a signal, like various examples you can give, like where daily we are examining the stock market, temperature predictions, lot of things are there, no? So they are all examples of signals. So we'll start the subject with a outside example. Okay, then comes the concept of independent variable, because based on the independent variable only we are going to classify the signal, whether it is one-dimensional signal, two-dimensional signal, or three-dimensional signals. And as far as any competitive exam is concerned, we are having only one-dimensional signals. So slowly we'll jump into the types of one-dimensional signals, namely continuous time signals and discrete time signals. I'm not going to reveal what is the definition of a continuous time signal and what is the definition of a discrete time signal now, but tomorrow anyway we are going to discuss. This is just a blueprint. What I am going to discuss, I have put in the slide. That's it. So we are going to discuss the nature of continuous time signals, how we are going to represent, what is the independent variable, what is the dependent variable, and discrete time signal, what is the independent variable and what is the dependent variable, how we are going to represent a discrete time signal, and what are the day-to-day examples you can give for a continuous time signals and discrete time signals and representations. All we are going to discuss in the third part. And the next part is, my dear students, I'm going to discuss the transformations of the independent variable. This is such an important topic that this topic is carried to the rest of the units. Transformations of the independent variable is very, very important topic, students. Okay, you go to the 10th unit, you go to digital signal processing, you go to any kind of speech processing or image processing, this topic will not leave you. Such is the importance of this topic, and every care is taken that each and every student from basic level will understand the transformations of the independent variable, like time shifting, time reversal, time scaling, how to apply. Suppose if you are given a combinations of shifting and scaling, shifting and reversal, how you are given, how many methods are there. See, the beauty of this subject is, already I told you that one problem here in this subject can be done in number of ways, not only one way. You can solve the problem in many ways possible, right? So we are going to discuss all the transformations of the independent variable for continuous time signals as well as discrete time signals. After that is done, let me tell you, this is the fourth one. For completion of this one only will be taking around 7 to 8 days, my dear students. 7 to 8 days dedicated on YouTube for the discussion up to transformations of the independent variable. All the possible cases we are going to discuss, and all the previous GATE and ESE questions are solved in the class only, and I'll assure you that every problem can be solved by yourself after going through the lecture. But your attendance is required. Sir, I'm coming for the first day, and so tomorrow I'm having some work, I'm coming for the third day. Means, let me tell you, you cannot solve the problems. You can understand the concept, but you won't have that much perfection. 1 hour dedication, 1 hour time you can definitely invest. Now, the next topic in the first unit, what I am going to discuss is the basic signals or standard signals array. See, our subject itself is signals and systems. So what are the basic signals we are having? Like impulse signal. How many ways you can generate an impulse signal? From step signal, how a impulse signal can be generated? From a exponential signal, how impulse signal can be generated? From a sampling function, how a impulse signal can be generated? From a Gaussian pulse, how a impulse signal can be generated? From a triangular pulse, how a impulse signal can be generated? From a rectangular pulse, how impulse signal can be generated? So all those concepts we are going to discuss. Impulse signal we are going to discuss, step signal we are going to discuss, ramp signal we are going to discuss, sampling function, sync function, signum, many basic signals we are going to discuss and their properties, because these signals are going to come in the future units. If you are not thorough with the fifth one, you will face a lot of troubles in the coming unit. Let me conclude that. Okay, after that we are going to have the classification of signals. So after studying these many basics up to fifth part, now what are the classification of signals? How we are going to classify these signals? So generally classification everybody knows: even signals, odd signals. Suppose given a signal, how we are going to break the signal into even part, odd part, and what happens if I add two even signals? What happens if I add two odd signals? If I multiply two even signals to add, if I multiply two odd signals, what happens if I differentiate an even signal? What happens if I integrate an even signal? Many concepts we are going to discuss in even and odd signals. And the next one is the periodic and aperiodic signals. And coming to periodic and aperiodic signals, as you know, the fundamental period calculation. So fundamental period of continuous time signal, how we are going to do, how continuous time sinusoids behave, how continuous time complex exponentials behave, all those concepts, and how discrete time sinusoids are going to come, how discrete time sinusoids are, discrete time complex exponentials are born. Everything we are going to discuss, and we are having many shortcut ways to find out the fundamental period by looking at the question, how to get the fundamental period in few seconds. All those concepts we are going to discuss. And then comes the energy and power signals. See, when can you say that a signal has a certain energy, or when can you classify a signal as power signal? By looking at the shape. And while discussing energy signals and power signals, let me tell you, there is a benefit for EC students that from this topic I'll directly jump to communication. Especially in digital communication, we are going to have something known as in the receiver matched filter. So in the matched filter, how we are going to calculate the energy of the signal, and how the signal to noise ratio of matched filter is related to the energy. So if you are going to relate one subject to with the other subject, you'll be benefited. And a lot of, suppose if I'm dealing with power signals, so in analog communication, how these power signals are useful, how to calculate the power of a sinusoid, and what is the principle of orthogonality, and what happens if the signals are orthogonal. All those concepts and examples we are going to discuss. And next comes the causal, non-causal, and anti-causal signals. This is very small part. I can complete this in only 10 to 15 minutes, because nothing to do much here in causal, anti-causal, and non-causal signals. By looking at the shape of the signals, how we are going to classify. Analysis is required for the future units, but here we are going to classify. And apart from this, we are going to have one more classification of my dear students, which is nothing but deterministic and random signals. That part also I'm going to discuss. So this is about the basics of signals and systems. And do you know how much time it will take to complete this course on YouTube on basic signals and system? Minimum 2 weeks. Minimum 2 weeks we can dedicate it to the basics of signals and system. And after this, the student must be in a position that he must be in a position to solve every question from any corner of textbook or any material or any test series. A problem is given, the student must be in a position to answer. That is the idea. Okay. And again, those who are, again I want to repeat, those who are coming new, please share and subscribe the channel. Unacademy, GATE English, lot of initiatives are going to come. Lot of initiatives. I don't want to reveal now, but lot of initiatives are going to come on this channel. Okay. The next unit, I mean signals and systems only. The first unit only. Here the next part is systems. See, what is the definition of a system? How do you define a system? How many types of systems are there? Continuous time systems, discrete time systems, and how you are going to interconnect the systems in different ways we are going to discuss. And apart from that, we are going to discuss the basic properties of systems, which are very, very important for any competitive exams or university exam, like linearity. This property you might have studied in networks also. Again, we are going to discuss this linearity property in detail. Time invariance. For every property, minimum 15 to 20 examples we are going to consider. Minimum. Suppose linearity is done means 15 to 20 examples. Time invariance is done means 15 to 20 examples. Causality. Physical realizability of any system is related to causality. With examples we are going to show. And again, 15 to 20 problems on causality. Static and dynamic. How can you classify a system to be static or memoryless, or how can you, say that a system is dynamic or a system with memory? All those concepts we are going to discuss. Again, then comes the important property, stability. When can you say that a system is stable? What kind of inputs we have to apply to verify whether a system is stable or not? Okay, lot of confusion. See, if I talk about this property, lot of confusion is there among the students, but everything will be removed after going to the concept. Invertible and non-invertible systems. Okay, so invertible and non-invertible system is also an important property of system. And after this is done, suppose if you are perfect with the basics of signals and systems, these two topics are done. What we are going to do is we are going to combine this first property, linearity, and second property, which is nothing but time invariance, and we are going to form a new unit known as linear time invariant systems, LTI systems, which is very, very important as far as signals and systems or control systems or communication is concerned. See, the first topic what I am going to discuss here is how to represent any continuous or discrete time signal in terms of impulses. Now, if you observe, I told you one point in the first unit that all the basics are covered in the first unit, but I'm going to use the basics in the coming units. Observe here, representation of a continuous time signal. Continuous time signal definition, as we have seen in the first unit. Discrete time signal definition, we have seen in the first unit. Impulse signal, we have seen in the first unit. Now we are going to combine all this. How we are going to represent a continuous or discrete time signal in terms of impulses. If I represent like that, what is the advantage? So that also we are going to discuss. So one important concept in LTI systems is convolution integral. Many students feel difficulty in solving the problems regarding convolution integral and convolution sum. Anyway, many methods are there. See, I don't say that convolution integral and convolution sum are done with LTI systems only. No. But they can be done with the other units also, but basic knowledge is very much required, right? What is folding, what is shifting, and how you are going to multiply for convolution, all those concepts we are going to discuss. Now next comes the properties of convolution. I'm going to discuss properties of convolution. Means various properties we are going to have, like commutative property, associative property, distributive property, and how you are going to, how previous questions are framed based on the properties of convolution, we are going to discuss here. And here next comes the properties of LTI systems. The properties of LTI system means based on impulse response, based on a concept called impulse response, how you are going to judge the causality, stability, and static and dynamic property and invertibility. So we are going to, I'm not going to give the properties, but I'm going to prove the properties in the class. Every student will be able to understand. Every student, we are going to prove every property of LTI system in the class. If you are able to prove, see, that's what I said, this is the right time to start the preparation for GATE 2022, because now if you start preparing, you can have more emphasis on the subject. Like if you get any doubt, suppose if I say some property, you may ask, sir, how it came. Now we have ample time so that we can derive the properties. Okay, you can enjoy the subject. And after the properties of LTI systems is done, we are going to discuss many numericals, many previous GATE questions on the properties of LTI systems. And the next concept is the step response I'm going to discuss. As impulse response we are going to discuss, there is one more concept called step response, and how impulse response and step response are related for a continuous time LTI system or discrete time LTI systems, we are going to discuss. And next comes the concept of unit doublet. Generally unit doublet, I mean this, from this concept, I mean never ever questions appeared in the exam, but most of the test series cover this unit doublet problems, but will postmortem this unit doublet, how this came and how to define this unit doublet based on some property of LTI systems. All those concepts we are going to discuss. And for the completion of this linear time invariant systems, LTI systems, minimum 1 week. Minimum 1 week is required. Minimum 1 week dedication is required, because we are going to, we must cover more number of numericals on LTI systems, right? See, if you're thorough with this topic, then comes the next unit called Fourier series, which is used to find the frequency content of periodic signals. Again, periodic signals means first unit. So we study the periodic signals. So its frequency domain representation we'll see in Fourier series. Again, how many types of Fourier series are there? Trigonometric Fourier series, and as you know, the other part is exponential Fourier series. So in trigonometric Fourier series, what, see, let me tell you that this Fourier series is important for EE students. EE students, especially for power electronics. For understanding the power electronics subject, they must be perfect. I mean, they must have strong base on Fourier series. They can play with power electronics. So Fourier series is an important unit for electrical engineering students and ECE and instrumentation as well. Okay, so here trigonometric Fourier series. So how to calculation of trigonometric Fourier series questions for different periodic signals, and simplification of a problem using symmetry. Suppose if the signal is even or if the signal is odd, how we are going to calculate the trigonometric Fourier series questions. And then comes how to draw the magnitude and phase spectrum. Many students feel difficulty with this one, so more emphasis will be taken care on drawing the magnitude and phase spectrum, my dear student. And after that, see, next is exponential form of Fourier series. And this exponential form of Fourier series is derived from trigonometric Fourier series only. So the derivation we are going to see, and relationship between trigonometric and exponential Fourier series, properties. Now comes the important thing, properties like linearity, time shift, time scaling, differentiation property of the exponential Fourier series, and integration in time, convolution in time, Parseval's relation, and how we are going to simplify the problems using the properties we are going to discuss. If you observe the ECE paper of GATE 2021, a question came from the Parseval's relation of Fourier series. A question came from Parseval's relation of Fourier series. And such questions, last year we have done many such questions in the class, and this year also we are going to do many, that is assured. Okay, and the next topic is LTI systems with periodic input. Suppose if you are going to feed an LTI system, second unit already we studied. Periodic signals, Fourier series, now we are studying. Okay, everything is an interlinkage here, interlink is there. Now what happens if I'm going to apply the periodic inputs to LTI system? What is the output? How the coefficients will change? We have to examine. So LTI system with periodic inputs, and after that I'm going to discuss discrete time Fourier series. Right? With this, Fourier series will be completed, and this minimum requires 6 to 7 days. 6 to 7 days. Right? Now coming to the next part, my favorite part, that is nothing but continuous time Fourier transform, CTFT. Very much useful for EC students, EE students and IN students. And EC students, let me tell you that if you are not studying continuous time Fourier transform, and if you are going for communication class, means it is of no use, because everything is dependent on communication. Half of communication is dependent on continuous time Fourier transform only, my dear students. Okay, here the first thing what I'm going to discuss is the definition of continuous time Fourier transform. What is the origin of continuous time Fourier transform? Basically, this continuous time Fourier transform came from Fourier series only. Came from the previous unit Fourier series only, by assuming the period to be infinite. Now, if I assume the period to be infinite, how the frequency changes? So all those concepts will be discussed in continuous time Fourier transform. That is the basic level. After that, every signal cannot have continuous time Fourier transform. What is the eligibility condition for a signal to have continuous time Fourier transform, which we call by the name convergence conditions or Dirichlet conditions? We are going to discuss with examples. And the next comes the important part, like basic signals, continuous time Fourier transform calculations, like rectangular pulse, impulse signal, and suppose if you are given a double-sided exponential signum function, how you are going to calculate the continuous time Fourier transform, and how you are going to use these basic signals and relate with the other signals we are going to study. And after that comes the properties of continuous time Fourier transform. And let me tell you, students, that whatever may be the unit, maybe Fourier series or continuous time Fourier transform, or the coming unit Laplace transform, Z transform, or discrete Fourier transform, properties are common. Properties are common and names are also common, but how they behave is different. Their behavior is different, but names are common. See, these properties, they make our life very easy. Let me tell you, they make our life very easy. See, in the basics, what we'll do is we'll try to calculate, suppose a signal is given, we'll try to calculate the Fourier transform from an expression. From an expression, what we are going to discuss in the first part. But whenever you are coming to the properties, we won't be using the analysis and synthesis equation, rather we'll be using the properties only. They'll make your life easy. They are like fast food. If you're not preparing food at your home, what we'll do? We'll go to a restaurant. So they'll see, restaurant means it makes our life easy. So, but which restaurant you have to go, that matters a lot. Here also which property, because one problem can be done using many properties. Many properties. So if you're thorough with the properties, I mean, that will be very beneficial in the examination, how to decide and when to use the properties. And that will come with perfection only. You have to solve more number examples, and that portion I'll take care. Okay, so what are the properties we are going to discuss in continuous time Fourier transform? Linearity, time shifting, area property. With example, again, let me tell you that if I am going to discuss a property, means minimum 5 to 6 examples. 5 to 6 minimum examples on my part. Again, I'm going to give some problems as, exercise also. Again, we are going to extract more problems from different sources, and I'm going to post that questions on Telegram, Unacademy GATE English Telegram channel, my dear students. Differentiation in time, differentiation in frequency, convolution in time, this itself takes. See, I took one special class in Unacademy. You can visit that class. Entire discussion, 1.5 hour discussion on this property only. convolution in time, what are the previous gate questions came, how you can solve more number of problems using this property. Already I have discussed, and I'll discuss more in detail on our YouTube Unacademy Gate English channel. Okay, and next comes convolution in frequency, the next property, and integration in time, Parseval's relation, or again this Parseval's relation came. See, whenever I see Parseval's relation, there is no such gate paper or ESE paper without this relation, directly or indirectly. You can take my word and check all the papers. Directly or indirectly, Parseval's relation comes every year. Every year. Then you can ask, sir, sir, what is, is it happened in GATE 2021? Yes, my dear students, you can check Parseval's relation from Fourier series. It came directly or indirectly. Every year a question is expected from Parseval's relation, and we are going to discuss minimum 10 conceptual based problems on Parseval's relation. And the next property I'm going to discuss is time reversal. Okay, so time reversal property I'm going to discuss, and conjugation and conjugation symmetry, and the previous questions based on these properties we are going to discuss. And for the completion of this continuous time Fourier transform, my dear students, I'll be taking minimum 8 hours, minimum 8 hours of duration only for continuous time Fourier transform, only for continuous time Fourier transform, for explaining and for making the students understand and solve the problems on their own. We are going to take 8 hours of time. And I know that many students are coming from the other channels also. You can, I have one thing to say, that I'm comfortable with Hindi also. I can, if you're not comfortable with English, okay, in the class you can ask me doubts in Hindi, and if you're not comfortable with Hindi, you can ask the doubts in English. Okay, I'm comfortable with both. And after that, the class starts at daily 7 p.m. to 8 p.m. are the timings, and based on the discussion with my team, we are going to have a lot of marathon sessions, previous gate question solving sessions, lot of things, and lot of initiations are also going to come, which will be relieving slowly. Okay, but we want the crowd. If crowd comes, we'll do lot of things above your expectations, right? Next comes the continuous time Fourier transform we have studied. Now, what are the applications? So this is an important part of the continuous time Fourier transform, distortionless transmission. Suppose if you are passing a signal through a system, now when can you say that we can have distortionless transmission? So what are the conditions on the magnitude response and phase response of the frequency response, what we are going to do? And the group delay, what is group delay, what is phase delay, what are the previous questions given, we are going to discuss. And the next unit, what I'm going to discuss in detail is Hilbert transform, and what is the relationship between Hilbert transform and the other type of transforms like Fourier transform. First of all, we are going to see that, and how Hilbert transform is generated, and what are its applications. So those who are coming from EC background or IN background, you might have studied this Hilbert transform in single sideband modulation. In communication, we have a topic called single sideband modulation, so where we are having a lot of advantages compared to DSB and AM. So how you are going to use this Hilbert transform in SSB, we are going to discuss, because it's a part of application. How it is useful in communication, I'll discuss. After that, I'm going to take a topic known as correlation, how to measure the similarity between two signals by using techniques known as autocorrelation, cross correlation, what are their properties, and how to calculate the problems, and what are the properties of autocorrelation or cross correlation, we are going to discuss. And concepts regarding pre-envelope, complex envelope also we are going to discuss. Most of the students feel difficulty with pre-envelope and complex envelope, but nothing to worry, everything is going to be easy from tomorrow, right? And the next thing comes is continuous time Fourier transform of periodic signals. Generally, this continuous time Fourier transform is calculated for aperiodic signals, but as a limiting case, You can calculate the continuous time Fourier transform for periodic signals. If you are going to calculate in the spectrum, what are the things that are going to appear like impulses, right? We are going to discuss, and how to calculate the Fourier transform of basic signals like impulse train signal, pulse train signal. We are going to discuss, and the previous gate questions related to this. And applications of continuous time Fourier transform will be taking around 3 hours to 4 hours, my dear students. 3 hours to 4 hours, because much of the time is dedicated to this one, because the next unit what we are going to have is totally dependent on continuous time Fourier transform, because in the starting only I said that everything is interlinked here, everything is interlinked. So the next unit is sampling. And before going to say what I am going to discuss in sampling, let me assure you, or let me tell you one important point, that see, we are not going to solve problems on sampling. We are not going to solve problems on sampling. Then what you are going to do? By looking at the problem, we are going to say the answer. What is the Nyquist rate and Nyquist interval calculation? Because all the basics of sampling are available in the previous units only. If I tell you how to calculate the Nyquist rate and Nyquist interval, then what will you be doing? If you are coming regular to the class, and if you are following my words, then easily you can solve the Nyquist rate and Nyquist interval calculation without putting pen on the paper. That is assured. And those who know me, KV Swamy, and you can ask the other students, I mean the previous students who have come to my class, you ask them whether we are going to do the same or not. So that is assured here. Okay. So introduction to impulse train sampling. How you are going to sample a signal, how you are going to multiply signal with impulse train, what happens in time domain, what happens in frequency domain, what is oversampling, what is critical sampling, what is undersampling, what is God band. All those concepts we are going to discuss, and how to calculate the Nyquist rate and Nyquist interval. And many times gate questions are based on this one. After sampling, what they'll ask you is, the sample signal is passed through a low pass filter or any kind of system. What are the frequency components coming out? So that will be discussed in the unit called sampling. And again, practical approaches of sampling. This will come in communication also, but as this involves signal basics, we are going to discuss here only. Natural sampling, flat top sampling, how we are going to avoid the aperture effect, and what is band pass sampling. So questions, many times questions are expected from band pass sampling, and how band pass sampling differs from impulse train sampling. And let me tell you that for the completion of this one, minimum 4 hours is required. Minimum 4 hours complete dedication is required because we are going to discuss the previous questions. All the previous questions will be there in your book. That is assured. Okay. Now then comes the next unit, discrete time Fourier transform. See, there is an offer. What is the offer? That electrical students, my dear electrical students, EE students, won't be having this DTFT, discrete time Fourier transform, how to find out the frequency content of discrete time aperiodic signals in their curriculum. But I suggest all the electrical students also to come for this unit, because the coming units, that is Z transform, is more dependent on discrete time Fourier transform. Z transform is just an extension to the discrete time Fourier transform. If you are thorough with the analysis of discrete time Fourier transform, you can easily understand Z transform. So electrical students, it will not be mentioned in your syllabus, but I always say that electrical students, you also attend discrete time Fourier transform. But how to get perfection on discrete time Fourier transform? Before coming to discrete time Fourier transform, you must have basics of continuous time Fourier transform. So if you are, here everything is linked. Everything is buy one get one offer here. See, if you're able to understand continuous time Fourier transform, then you can easily understand discrete time Fourier transform. If you're able to understand Laplace transform, definitely you'll be able to understand Z transform. If you can understand continuous time signal behavior, you can understand discrete time signal behavior. If you can understand convolution integral, you can understand convolution sum. Buy one get one offer is there. So discrete time Fourier transform. Here what we are going to discuss, Here, first of all, we are going to discuss the analysis and synthesis equations of discrete time Fourier transform, as we have done earlier also. So convergence conditions, discrete time Fourier transform of basic signal. This will be done in every unit. Whatever the unit I take, whatever the transform we take, first of all, we'll calculate for basic signals and we'll use those basic signals in the other coming sessions. And next comes the properties of DTFT, periodicity property, linearity, and how the spectrum how the spectrum behaves in DTFT. So spectrum of continuous time Fourier transform is entirely different from spectrum of discrete time Fourier transform, and how to remember easily all those points we are going to discuss. Time shifting property, frequency shifting property, time scaling property, differentiation in frequency. If I talk about this differentiation in frequency, electrical students, see, a question came from this property in GATE 2021. GATE 2021, you can verify. The convolution in time. Again, whenever we encounter this word called convolution in time, already we will study how to perform continuous time convolution and discrete time convolution in our second unit. But the same thing, the other method is done by using this property, convolution in time, convolution in frequency, and Parseval's relation. Okay, so we cannot go without Parseval's relation. In the coming units, we won't be having Parseval's relation in Laplace and Z, but up to discrete time Fourier transform and coming DFT, we are having Parseval's relation. And let me tell you that if I'm talking these many terms, second year students may feel that, how to remember all this? Nothing to worry. You have to invest 1 hour time daily. You can invest 1 hour time daily. You will be perfect with all the basics of signals and system. And I suggest all the students to spread this information or to share this information to others also, right? So some students will say that, sir, I'm from lateral entry. What will happen? We are going to discuss everything from basics. So until you understand, I'm not going to leave the problem. Until all the students in the live chat are going to say yes, I'm not going to move to the other problem, right? Such kind of care is taken here. That is the importance of Unacademy GATE English channel, and lot of initiatives are also going to come, right? Determination of a filter from difference equation or transfer function. Sometimes they'll give a difference equation or a frequency response they give, and they'll ask you what kind of filter it represents, either low pass filter or high pass filter, band pass filter, band stop filter, band reject filter. How to determine the type of filter we are going to discuss. Okay, and so many things are there here. I'm not writing everything on these slides, right? So here for the completion again, so 5 hours minimum I require. 5 hours minimum I require. Name comes Laplace transform, your favorite unit, Laplace transform. Most of the students might be happy at this time. Laplace transform came because you people will be studying this Laplace transform in mathematics also. Okay, same kind of analysis is done here also, but we'll be doing with respect to a system here. Okay, here what is the need of Laplace transform? So when we have Fourier transform, what is the need of Laplace transform? So that we are going to discuss analysis and synthesis equation. What is the concept of ROC, region of convergence? We are going to discuss. And what is the actual definition of ROC? We are going to see. And Laplace transform of basic signals like e power minus at u of t, minus e power minus at u of minus t, u of t minus u of minus t. Laplace transform of basic signals, all the basic signals we are going to discuss. And then comes the properties. And let me tell you an important point, that Laplace transform also makes your life easy. How it makes your life easy? See, 2 advantages I can tell you. If while performing convolution, second end already we'll study convolution. So same kind of problems we'll try to do it in Laplace transform. And the other advantage is, if you're thorough with this unit called Laplace transform, you can understand easily the unit called transient analysis in your networks. So transient analysis, there is a concept called transient analysis using Laplace transform. So transient analysis becomes very easy for you. And we are going to discuss the properties. The first and foremost property is linearity, time shifting in S domain property, and properties with examples. If I'm studying the properties here, means properties with examples, minimum 4 to 5 examples. Okay. Differentiation in S domain, differentiation in time, convolution in time, integration in time, lot of properties are there. And I'm going to introduce the next topic known as unilateral Laplace transform, and how unilateral Laplace transform differs from bilateral Laplace transform, and how you are going to solve the differential equations using this unilateral Laplace transform. What is zero state response, what is a steady state response, and what is initial value theorem, what is final value theorem, where final value theorem fails, what are the conditions, all those concepts we are going to discuss. And apart from that, we are going to have one more topic, analysis of continuous time LTI systems. That is how you are going to judge the causality and stability. Causality and stability, let me, my dear students, given input output relationship, we are going to study in the second unit. Given impulse response, we are going to study in the LTI systems. Suppose if you are going to give, suppose if you are given a transfer function, we are going to analyze the causality and stability based on Laplace transform. Okay, this is an important topic for GATE. Important. After that, how to calculate the Laplace transform of switched periodic signal. What is a switched periodic signal, or what is the causal periodic signal? How to make a signal switched periodic, and how to find out the Laplace transform we are going to discuss. And I'm going to discuss some more topics like waveform synthesis and how to calculate the Laplace transform of all those in this Laplace transform only. And for the completion of this unit, I may require around 5 hours. 5 hours time investment is required, my dear students. Okay, now let's come to the next part. Z transform. Z transform. Z transform is nothing but the discrete counterpart of the earlier unit. Buy one get one. If you are perfect with Laplace, same kind of problem, same kind of properties, everything will be coming in Z transform. But Laplace transform is calculated for continuous time signals, whereas Z transform is calculated for discrete time signals. So analysis and synthesis equation, this is common for every unit. So based on analysis and synthesis equation, we have a lot of problems to be covered in Z transform, which are given in previous GATE exams. And how to calculate the Z transforms of basic signals. Basic signals, I mean like a power n u of n minus a power n u of minus n minus 1. Basic signals are given. How to find out the Z transform. And properties. Next, linearity, time shifting, scaling in Z domain, time scaling, differentiation in Z domain, convolution in time, cost difference and accumulation. And here properties means properties with examples. Properties with examples. Right. After that, we are going to discuss unilateral Z transform. Observe here, unilateral Laplace transform here, unilateral Z transform here, and how you are going to solve the difference equations using unilateral Z transform we are going to see. Here differential equations will solve using unilateral Laplace, difference equations will solve using unilateral Z transform. And after that, how to analyze discrete time LTI systems. So analysis of discrete time LTI systems is very, very important in GATE or ESE point of view. That is how to judge whether a system is causal or stable based on the transfer function we are going to discuss. Again, digital filter determination using Z transform. See, again, digital filter determination already we have done in discrete time Fourier transform. Okay, as Z transform is extension to discrete time Fourier transform, how you are going to judge the type of filter based on the transfer function. Based on the transfer function, what values of Z I must put, so that I can classify a transfer function into a particular system, particular filter we are going to discuss in digital filter determination using Z transform. and relation between S plane and Z plane we are going to discuss here. And for the completion of this Z transform, minimum 6 hours of duration. Minimum 6 hours of dedicated duration is required. And coming to the last unit of GATE, that is nothing but discrete Fourier transform. Discrete Fourier transform, right? Continuous time Fourier transform will discuss, discrete time Fourier transform will discuss, discrete Fourier transform. Basically, this discrete Fourier transform is a topic for ECE students or IN students in the third year of their engineering, third year. And let me tell you that electrical students, you are not having discrete Fourier transform. You are having a discount. You need not bother about discrete Fourier transform, right? But if you want to gain knowledge, then you can happily attend, because as we know that all these concepts are interlinked with the previous ones only, right? So here I'm going to discuss first of all what is frequency domain sampling. What is frequency domain sampling? See, in the previous unit we have seen the sampling technique, that is time domain sampling. So frequency domain sampling, because this technique called DFT comes from DTFT, discrete time Fourier transform by frequency domain sampling, and DFT analysis and synthesis equations, and DFT of basic signals we are going to discuss, and the concept of circular convolution, very important. So linear convolution we'll discuss in the second unit, but circular convolution we are going to discuss here. And is there a relationship between linear convolution and circular convolution, and how to get that one using DFT? All those concepts we are going to discuss, because GATE 2021 ECE paper, if you observe, a question came on this topic, DF3 used through linear filtering. There is a topic called DFT through linear filtering. So that question appeared in GATE 2021. So if you are going to discuss 2 or 3 basics, then you can easily answer that question. So you need not bother. Again, properties of DFT like periodicity, linearity, circular time shift, circular frequency shift. Here everything will come in terms of circular. Why the term circular is coming, we have to discuss, and partial solution, etc. So these are the properties we are going to discuss. And for the completion of this discrete Fourier transform, 5 hours of duration is required. So these are the topics we are going to discuss, or this is the blueprint, my dear students. This is the blueprint of our course, right? Now you can assume how many topics we are going to cover. You can take a note of this one, or I'll be uploading this one in the Unacademy GATE English Telegram channel. You can take you can download this one, and you can verify whether we are going to discuss all this or not, and you can ask if any topic is missing. That is assured. That is assured from our side. Okay. And after discrete Fourier transform, and next comes what books to read. No. What books to read? Question naturally comes to your mind. What books to read? So these are the books we are going to have. These are called reference books. What are these known as? Reference books. Here I am writing some books, means it doesn't mean that you have to take a pick of this one and go to a bookstall and buy all this. These are only for reference only. Reference only means you're coming to the class. You're coming to the class. If you got any doubt, go to the book and discuss. You can clarify your doubts, but don't read the book until and unless I tell. Unless I tell, don't go through any book, because these are standard books. After our discussion, if you go through any of these books, you can easily understand. You can easily understand, and you're able to solve the problems also. That's why I wrote reference books. Reference books. And on the net, many ebooks are also available. You can type in the Google Signals and Systems Alan V. Oppenheim PDF, means it will come. So no need to invest money also, right? First one, Signals and Systems by Alan V. Oppenheim. This is the best book. Not only me, then who is, those who teaches Signals and System, ask them. The first name that comes is Alan V. Oppenheim. Such is the importance of this book. You observe any lecture of any faculty, any teacher who teaches signals and systems, and ask the book. First word that is coming, or I mean, from their mouth is Alan V. Oppenheim. And this is such an important book that this is written for graduation level, post-graduation level, and research level. That is the level of this book. Very good book, and I forgot to write here. Second edition you take. Second edition, and here S. Hamid Nawab must be there. S. Hamid Nawab must be there. Right? This is the, I mean, very good book. And the next one is Signals and Systems by M.J. Roberts. See, I observed many, 2 or 3 times, the gate questions were directly extracted from this book. I observed 2 or 3 times. Gate questions were directly extracted from M.J. Roberts. Such is the importance of this. And Signals and Systems by Simon Hakin. This is also a good book. And Linear Systems and Signals by B.P. Lathi. I think most of the students might be knowing this one. Many times if I say book means, they'll say B.P. Lathi. And if I say B.P. Lathi, I mean, they'll start laughing because they know his name. They know this name. Familiar name, B.P. Lathi. There are many versions of B.P. Lathi, but you try to prefer this one. Linear Systems and Signals by B.P. Lathi, Oxford University Press. And suppose for EC students, if you want to gain knowledge on this digital signal processing, go for this one, Digital Signal Processing by Prokis. This is a good book. And problem solving, many problems will be solving in the class only, and will be giving the questions from different sources. No need to worry. Apart from that, if you want additional problems, if any problems are left, means you can refer these two books, Signals and Systems by Ram Series and Gate Problems by R.K. Kanodia. You can refer these two books for problems, right? And the next part is expectation. So I told what I am going to deliver for the coming sessions. Now this is from my side, expectation from students. What I am expecting from the students. The first one, what I am expecting is very, very important. Put 5 stars for this one. How many stars? 5 stars for this. What is that? Regular attendance without fail. You cannot question without coming regularly. You cannot say that I'm unable to understand that topic. You must come regularly. If you are coming regularly, it is our job to make you understand. So regular attendance without fail. And the class timings are from 7 p.m. to 8 p.m. Okay, very convenient time for all the college going students or those who are working. Convenient time, very convenient time. 1 hour. The Unacademy Gate English channel must be a part of your life. Like all the channels will see Big Boss and all thing. Many shows will come. No, so as we are going and sticking to the TV, by the time the show comes, by 7 p.m. you must be into the Unacademy Gate English channel. So regular attendance without fail. See, it is for you, it is for the benefit of students only. What I have written. Okay, you only will be benefited. If you're coming regularly, you will be benefited. You cannot say that, sir, I'm having semester exam, or if semester exams or internals are there, many things you are going to do. So apart from that, you can do this class also. So whatever may be your exam, so 1 hour investment is not a big issue. Only 1 hour investment we need. And before coming to the class, go to the previous class notes. Why? Because every unit is linked to the previous unit. Already I said in the beginning only, every unit is linked with the previous units only, right? So if you're coming prepared, what is the advantage? You can answer in the class. You have advantage, right? So before coming to class, you see, before coming to the class means not if I'm starting the class at 7 p.m. it doesn't mean that you have to start reading at 6 p.m. After the class you have to study. That is the thing. Okay. And sincere dedication towards homework, because many problems I'll be giving as homework. Because if I say that, sir, I'm going to teach, definitely around 1,000 problems we are going to handle in the class. But if I solve each and every question, it makes no sense. Like it is simply like learning how to drive a car on YouTube. I don't want that to happen. So you must be dedicated towards your homework. So homework also hardly it takes 10 to 15 minutes. 10 to 15 minutes, 1 hour class, at the most 20 minutes for homework, right? Anybody can spare. If you're not having time, you have to pull the time, because nobody in this world is having time. You have to pull, no option. Interaction in the live class, right? See, whenever the class is going on, see, it must be bidirectional, not unidirectional. Always I teach, you listen. So there must be interaction between the teacher and the student, and I am expecting something from you students, that see, whatever the experience I'm having, first slide I've written, no, some 12+ of years experience. In that experience, I learned many things. How I learned many things? In the form of doubts. In the form of doubts, right? And so if there is interaction between the teacher and the student, the class will be very nice. And I'm expecting a valid doubts only. See, before going to ask the teacher, you must verify whether it is valid or not, because the class time should not go waste also. That is also that you must take care. Must have fire towards your goal, right? See, whenever you are coming to the class, means you must have some intention. See, if you're reading a book, means you must have some, I mean, goal towards. See, first of all, set your goal that I have to get a single digit rank in GATE 2022. So when you I mean, if you have an idea and if you discuss that with your friends, that I'm going to have single digit, they laugh. Let them laugh. Let them laugh. Nothing is going to happen. So you must have a fire. If you have fire, nobody will stop. So you take valuable input from the teachers. How to get good, I mean, single digit ranks. Many single digit ranks are there in our channel only. I think you know the names also, right? So you must have a fire towards your goal, right? And you must have hardworking nature. Why hardworking nature? Means sometimes it is very difficult to understand a topic for you or for me. That is human psychology. If you're not understanding, I mean, if you're not understanding in one go, you have to put some extra effort, right? So that requires hard work. So hardworking nature. So if you're having all this, and if you're coming regularly to Unacademy GATE English channel, nobody is going to stop. And if you're coming regularly, you can demand us that we want this kind of initiatives. We want a marathon session on this one. We want a discussion on this one. If you're not coming regularly, our team leader or our head, nobody can take any initiatives. So if you want many initiatives, share the channel, subscribe the channel, and spread in many ways possible, right? And the next thing, you can follow me on Unacademy. So unacademy.com/KV Swamy, and fine. And these are the channels what we are going to have on our Unacademy. Right. The first one is the Creatric GATE ECIN, GATE MEPIXE, and you can spread information that if anybody is from mechanical engineering production, you can say that our Unacademy GATE channel is there, where I mean, many YouTube sessions are going to happen, many free subjects. I mean, you can learn the subject for free. Unacademy Civil Engineering and Chemical, Unacademy Computer Science, Unacademy GATE questions, Unacademy Computer Science by Ravindra Babu Rawala. This is a newly added channel, a feather in the hat. Okay, Unacademy GATE English is our channel. And Electrical Junction and Apti Express, these are the channels. And I want all the students to subscribe the channel, share the channel in all the possible ways, so that you only will be benefited. Because if you are coming in large numbers, our team is going to come with many initiatives. From tomorrow onwards, we are going to have campus training by Sharma sir, who takes aptitude throughout the country. I think it is at 5 p.m. So if you're coming regularly, you can have so many initiatives you can demand. And finally, thank you. If you want to say anything, you can, type in the chat. Or you can change timing, please, because power system class is also going parallelly. We'll look into it, Surya. Look into it. Reference book. Already I told you, na. Many reference books I told you. Many reference books I gave you. So tomorrow's class I'll give you. Good evening, Kambabu. So what I want is you spread the channel, you spread the channel, you spread the channel. Please provide PDF notes. That is definitely, that is assured. Even the PDF of the thing what I'm saying, that also you'll get. Okay, thank you. This is from my side, right guys? So we'll meet tomorrow at 7 p.m. on Unacademy GATE English channel. And again, I'm saying, if you're not subscribed, please subscribe, share the channel and spread the information in many ways possible. Okay, the show will start tomorrow. Thank you, my dear students.